Good afternoon, everybody. Let's get started. My name is Bill Newhall. Welcome to, let's see, the course number is MCEN 4228 or 5228, depending upon if you're in the undergrad or the grad section. It's called Practical Electronics, no matter which section you're in. So today I'd like to go over an introduction to the course and tell you what's coming up and the motivation for the course. And then if we get some time, start covering in on some material. So welcome to the course. I'd like to let students know who I am. I think you should always ask who your instructor is, who's teaching you. I am an electrical engineer by education and profession. So I've been teaching for over 20 years now. I've also been working as an electrical engineer for over 20 years now. And I've been teaching an intro to circuits and electronics course for the mechanical engineering department for quite a while now. And that was an introductory course that took students from, well, basically ground level kind of physics knowledge of electronics all the way through some lab work and some practical understanding. But there was a need, a desire a couple years ago to put together a course for graduate students and some undergrads who wanted to advance their knowledge in more practical applications of electronics. So I put this course together. This is the second semester that I'm teaching it. We taught it last year. It worked out pretty well last fall, and we got to work through some of the bugs. So you'll get a little bit of a cleaned up lab experience, which I think is good. But we're going to focus on practical aspects of designing circuits and understanding circuits. And I think these topics apply to really a lot of non-electrical engineers. So if you're in an engineering field or any technical field, and you'll probably wind up interfacing, dealing with electronics and electronic systems. So that's what this course is meant to do, is to kind of build upon the intro course and give you some more practical knowledge. We're going to cover test equipment, test and measurement equipment, power sources and controlling power sources, microcontrollers, a little bit of software. We're going to talk about different kinds of sensors. We're going to talk about communications over networks, Internet of Things, and a little bit of RF communications. So we cover a lot of topics, but I think it all comes together, especially in lab, to be a cohesive set of what people want to know in electrical engineering or about electrical engineering when you're not electrical engineers. So I've been doing this for quite a while, probably about 28 years working as an electrical engineer. I focus on building radio frequency electronics and related electronic systems. And I've done all sorts of things. I've served roles in detailed design, systems engineering, system level design. I've done technical leadership on programs. I've led product efforts and research and development efforts, and all the way to new business pursuits to try to bring in new projects. So I've been doing this a while, and I like to say teaching is a calling of mine. So even though I work as an electrical engineer, I really do enjoy teaching at the college level and some short courses in industry. And what really drives me, I like seeing things work. I really enjoy practical, hands-on engineering. I like designing something, but I also like then seeing that work and making sure the design it does what I thought it should do. So I get involved in a lot of test and demonstration efforts, and I enjoy the design and I enjoy the test and demonstration. But I think those, if you can do both of those, it's really a rewarding experience, and I want to bring that to this class. On the side, I'm a pilot. I'm a commercial multi-engine instrument-rated pilot, and but I just fly privately, and I'm an amateur radio operator. If you've heard of ham radio, I do that. And you're going to see some influence of that on this class. You're going to see that we have sort of an aviation-themed project, and I mix in some radio frequency communications in here. So my intent is to leverage this experience and bring in some practical topics, practical experiences that will hopefully help benefit you as you launch into your career or as you're in your career now, just to augment what you have in your current engineering background. And I like to bring in practical examples relevant to mechanical engineers and those problems or solutions that non-EEs would likely encounter. Okay, so you're going to see a mechanically oriented control system as your project in lab. So this course, the objective is to cover all the topics applicable, many topics applicable to a wide range of electronic systems that impact non-electrical engineers. So I'm going to build up a slide here that shows these different topics that we will cover in this class, and that I think are important for really all engineers to have some exposure to. So we're going to talk about electromechanical devices or otherwise physical devices like DC motors and solenoids and actuators. So you can think of these, anything that a circuit might interface with to either sense or control. I tried to include many aspects of this in the course. And if you're controlling a electromechanical device, then you're going to need some kind of control. So we're going to cover microcontrollers and MOSFETs. You also might want to sense physical characteristics of your system. So for example, light or infrared light, temperature, weight, acceleration, gyroscopic forces or rates. And then every core or every circuit, every system needs some kind of power source. Okay, so whether it's a battery, solar powered, wind powered, or powered off of the AC network or AC power system. And oftentimes the power source isn't sufficient to provide the voltages or power that you need for your system. So there's power conversion. We're going to talk about DC to DC conversion and linear regulators. And then oftentimes you want to control your electronic system externally. Right? So you need some kind of communications and control with your system. So we're going to talk about communicating over the internet, communicating over radio frequency. Okay, so highlighted here are the specific topics we're going to cover in lecture and in lab. So you'll get your fill of theory here and hands-on work with all of these highlighted topics. And also considering what students have wanted in the past. So I do a survey generally, either at office hours or in a course. You know, what do you wish you had learned in the intro course, or what do you wish we would have covered and didn't have enough time to cover? So I've taken notes on those, and so these are many of those topics. I also went out into my colleagues at work and I said, hey, you're a mechanical engineer. What do you wish you would have covered? So, you know, they may be 10 years into their career and they say, you know, I really wish I would have covered a little bit more of RF communications or how to control electric motors with a MOSFET. And so that's also built into this course. Okay, and the topic areas are meant to cross engineering disciplines and industries or research activities, right? You may be going out into product design. You may be going out into, after you graduate, to perform research, but I think these topics are relevant to whatever you do next. Okay, so who should take this course? Mechanical engineers. This course was primarily designed for mechanical engineers, but really any non-electrical engineer could take this course to strengthen knowledge in electronics. And also electrical engineers have been interested in this course because it applies much of the theory that we learn in electrical engineering, but often don't get an opportunity to implement, okay, to actually see it work in lab. Okay, so the major topics I selected based on electronics functions that are common across electromechanical systems. So we're going to review circuit theory. We're going to start out the course, spend maybe 3 lectures reviewing circuit theory and analysis. But instead of just talking about Ohm's law, KCL, KVL, I'm going to show you some practical applications where you can be helped or you can avoid getting into trouble by applying these basic circuit theory concepts. We're going to talk about electrical test equipment and measurement of circuits. And so this will get you set up for doing more advanced measurements in lab with the lab equipment that we have. We're going to talk about power sources and controlling power sources. We're going to talk about sensing and control with microcontrollers. So how do you use analog to digital converters? How do you condition a signal from a sensor to match the range of an analog to digital converter that's part of a microcontroller, right? So these are topics that I think will come up no matter what you're doing. If you have some kind of circuit or if you have some kind of system that needs a sensor or needs some kind of control, we're going to touch on these topics. Right, we'll talk about those specific electronic sensors, talk about temperature sensors and light sensors and strain gauges and electronic gyroscopes, things like that. And then we'll talk about device communications. We'll get into the Internet of Things using a protocol called MQTT, where you're actually going to be publishing data to a network in the lab from your lab work that you will be doing. And we're going to be doing that communications over radio frequency. So we'll talk a bit about RF communications. You know, for example, how do you know how far you can establish a communications link? You know, just to the next bench, across the lab or across town based on transmit powers and antenna characteristics. We'll talk about that. And we'll finish up talking about, well, what if you wanted to get into electronic product development? What's it mean what are the steps going through concept, through design, through laying out circuit boards, through producing circuit boards and testing? Okay, so we will spend the rest of the semester talking about these topics. So some of you may have experience in some of these topics, right? That's great because I hope to strengthen those or at least let you exercise those with some practical applications. There is a minimum background, I guess I would expect coming into this course. I expect that you've had some kind of circuits study or circuits class, maybe beyond intro physics, right? With some kind of lab exposure. So you've touched an oscilloscope at one point, or you turned on a power supply, or you know what a breadboard is, right? So you should have familiarity with current, voltage, and power, although we will review basic circuit analysis concepts, Ohm's law, KVL, KCL. You should recognize on a schematic sources, resistors, capacitors, and inductors. Maybe worked with diodes, or at least know what a diode is, and I've worked with diode circuits, maybe a transistor circuit, possibly worked with DC motors, right? If you've ever powered up a DC motor from a battery, it's probably the experience you need. We'll talk more about controlling the speed of a DC motor with a microcontroller. And then we're going to jump into some digital topics with microcontrollers. So you should understand what a binary value is and what bits are, and have some experience building a circuit on a breadboard and then taking basic electrical measurements. Okay, so I would expect many of these topics are familiar to you. You probably have some background. If you're missing something here, that's okay. I'm going to show you some review material that you can go brush up on theory with short videos, and then some references where you can see, other people other than me talking about these topics. Okay, so this course is going to have lectures, and we're going to cover theory and practical considerations across all those topics. We're going to have these live online lectures, and we're a fairly small class. We have about 24 people other than me on this call. So I encourage, if you have a question, shout out your question, unmute, stop me if you want to talk about something in a little more depth. Shoot me a chat. I'm keeping the chat window up, and I encourage discussion and questions. And if we're running out of time, I might say, hey, let's continue this toward the end of the class or at office hours. I'm going to record these lectures and post them, so you'll have links on the Canvas website so that you can come back and review, or if you have to miss a lecture, you can watch the lectures. In lab is going to be a guided development of a system. It's going to be focused on hands-on building in lab and measurement and test using the test equipment. So the intent is to learn the theory and do design outside of lab, and then go into lab and get hands-on there. These lectures will be posted, so I'm recording these via Zoom, and you'll have links to these lectures. Canvas is where you will find all of the assignments, all of the links to the references, all the general course information. I'll show you that toward the end of this lecture today. I've set up a Slack page, so if you have any question about homework or lab or studying for an exam, something like that, post those questions to Slack, because what that lets me do is I get a question, I can answer it, and it may help others. So I'm going to use Slack as a technical discussion forum. And we're going to use clickers, so I hope you have your clickers set up. If not, maybe you can get those set up really quick, because I'm going to take some surveys at the beginning of this lecture to try to find out where the class is and what our starting point is. And if you have any problems with video or audio, you can't hear me, you can't see what I'm showing, it's too small, whatever, please let me know, and shoot me a chat or shout out. Let me know if something's out of focus, you can't read when I'm on the whiteboard, my writing, or just let me know. I want to make sure you can see everything that is being presented. Okay, so there is my contact information. My office hours are posted on the Canvas page. Generally, they are right after class. So just stay on this Zoom session if you want to chat, and I'll keep the Zoom session up, and we'll start office hours right away. And we have a teaching assistant who will be joining us, so we'll get help in lab. So there will be 2 of us covering lab, so you get lots of help in lab. For references, you'll have these lecture slides. So all my lecture slides are posted on Canvas. There's no required text, and there's no one textbook that covers all of this material. You'd have to buy a bunch of textbooks, and then all the practical material, much of the practical material would not be covered. So what I do is I have posted an index of references on Canvas, and there are online reading references and videos. I've posted application notes from parts manufacturers. Also, if you want to review, I have videos posted and indexed from my intro course, and I'll show you that. There are also resources in the ITLL, and there are workshops, and I'd encourage checking these out. There's always something you can pick up out of one of these workshops. So the ITLL Electronics Center, so our lab is in the ITLL. That's where we will hold lab. They have staff and equipment, staff to help you out, lots of equipment to perform your lab work. We'll talk about that. And there are workshops. So I'd encourage, for example, if you haven't done soldering or you're rusty on soldering, go take the the intro to soldering workshop there, and they'll tell you all about how to use the equipment, how to solder, how to desolder, how to fix things, how to temporarily solder. And also, if you want to brush up on simple circuits and basics of measurements with the lab equipment, there's also an electronics workshop. All this is linked to the Canvas page. So you'll see these resources. There's an Arduino workshop. Our microcontroller that we will use is an Arduino, so it's got the Atmel microcontroller chip on it. So there are a couple. If you want to get up to speed, if you haven't touched one before, it might be good to try out working with an Arduino at one of these workshops. And also, there's a prototyping workshop if you want to do anything with 3D printing for your project. We'll talk about the project, but there's a structure. So if you don't know how to do that yet, it's a good opportunity, good reason to go learn how to use the 3D printers at in the ITLL. Okay, so the labs are meant to put the lecture material into practice. So here is a cartoon of your project. It has all of these sub-circuits, subsystems, power, microcontroller, a motor driver, infrared RPM sensor. It's connected to a network over Wi-Fi. You'll be doing some software. So we're going to cover these topics in lecture like this. We're going to cover power sources. We'll talk about batteries. We'll talk about DC to DC conversion, how that works, the different types of DC to DC converters. We're going to talk about controlling power delivered to well, really any load, but in this case, a motor using a MOSFET motor driver. So you're going to have a bare printed circuit board that you will get in lab. You'll build up your motor driver. You'll connect it to a microcontroller, control that motor. And then you're going to use the microcontroller to sense the RPM of the motor, of the propeller, using this RPM sensor. You'll write some software for that. Most of the software is going to be, it's going to start out with a template. So you don't have to file new and write from scratch. You're going to have a template of software where you can modify it. We're going to talk about temperature sensors and light, infrared sensors, light sensors. What else we talk about? Magnetic field sensors. So, and then you will implement temperature sensing and infrared sensing in lab. And then we're going to connect this whole system together, your whole project together, using IoT and RF. But we're going to start out in the beginning of the course talking about basic circuit theory and analysis because it applies to everything here. We're going to talk about electronic test and measurement. And then at the end, electronic product development. Like if you wanted to take this and make a circuit board and fabricate something as a product, what are some design steps that you would use? So the lab is really meant to strengthen your hands-on building and testing skills with electronic hardware, mechanical hardware, some light software work, and analog signaling, digital signaling, and wired and wireless comms. So that's what we'll get into in lab. The lab is designed to help you learn the practical topics. So what you're going to do is you're going to work with a partner. So our first lab will not be this Friday, but the following Friday. So if you want to find your lab partner before you show up at the first lab, that's fine, but expect to be working with a lab partner. And you're going to incrementally develop this project throughout 10 labs throughout the semester. And so we're going to have weekly lab sessions to support your lab work, and attendance is required at the lab because we want you there so that we can help solve any problems. We can keep the whole lab going forward at the same pace. Okay, let's see. So you might anticipate some lab work outside of the regular lab session. For example, the first lab is going to be designing the structure on which you will mount these electronic components. So that means, you have a 2-hour lab session, you might start designing what you want to build, but I would expect if you're going to go 3D print, if you're going to go get some wood, get some metal to build up the test bed structure, then that's going to take some time outside of lab. So you might expect that. The lab sessions themselves will be held in the ITLL. We'll use the ITLL test equipment. It's some pretty good equipment. It's fairly modern. I think it's been there for a few years, but by far, I wish I had all this equipment set up on every bench wherever I worked. So it's pretty good. You're going to have an electronics kit that will be given to you. It's going to be issued to you during the first lab. It'll have discrete components and the microcontroller board, the bare circuit board, and everything you need for the electronics part of your project. And then the mechanical part, you might need to be creative with your own materials. So the ITLL does have tools and minor materials available. So if you can find all the materials you need in the ITLL, great. If not, you might need to obtain otherwise from scrap piles, or if you want to purchase materials for your project. And I'll describe what it is. It's nothing too elaborate, but it's going to take some materials and some time. If you don't have a computer account already in the ITLL, please see this web link. In order to get after hours or extended hours access to the lab and to get access to the computers, you have to take an orientation tour, which is worth it. You can see what's there and what resources are available to you. All right. So assignments, there will be homework in this class. I actually encourage working with others on this homework. So because there's usually more than one way to solve these problems. You're going to see some very practically oriented problems. And so if you work problems multiple ways and come up with similar solutions, then you've got that's like having a design review, right? But in the end, I ask that you submit your own homework, and please do that prior to the due date and due time that is posted on Canvas. So you'll see, I'll give you a tour of the Canvas page, but you'll see under assignments, there's a due date and a due time. So please submit your homework prior to that, your assignments prior to that. And Canvas allows, this is not so true anymore. I got to update this. I've switched from the Canvas mode of collecting homework results to, you'll see, to a web form, because Canvas was messing up last semester, especially when more than one answer could be accepted. It was not allowing that very well. So anyway, we worked out that bug last fall, and you'll see how to submit homework when I show you. And then there's this free credit question at the end of the submission page. I think it's a required question, but click on it. Trust me, it's just a way to give partial credit for questions. There will be 3 exams: exam 1, exam 2, and a final. And you'll work individually and remotely on the exams. Okay. So in lab, so you're going to have a lab partner, so teams of 2, and each lab team should submit 1 report in Microsoft Word or PDF format. And so again, see the due date and time on Canvas. And what you're going to do is you're not going to write up your own report from scratch. You're actually going to use the assignment file as the report template. So there are spaces in the assignment file to insert measurements and plots and data and photos and schematics. Right, there are some placeholders. So you'll take a picture of your project, or you'll capture a graph and you'll enter that into your report. You'll also type data into tables. So this is the way for a couple of reasons. One, because it's an assignment, it has to be graded, but also so that when you get a couple labs ahead in your project, if you're having a problem, what we're going to do to troubleshoot is we're going to go back a couple labs, we're going to check the data, and we're going to compare it to current measurements to see if anything has changed or anything has broken. Right? So that's the purpose behind collecting all this data and these plots is not just for busy work. It's actually to have data so that when we move forward and we integrate with the battery and the DC to DC converter and the motor and the microcontroller, that when something's not working, we can take individual measurements of those components and go back and check it against your data that you've taken. Okay. And so bring a USB stick for acquiring data from the test equipment. Bring a phone with camera so that you can take photos of your project or photos of subcircuits. Okay. And also, please use this has just started coming up. Please use like a Microsoft Word editor on a PC to enter your data and your plots into the templates. We had a problem where if you use another app, even though it claims to be compatible, the formatting gets messed up, the data doesn't show up right in the tables. And so, so please use the assignment file for the lab and then enter that data in on a PC or whatever you have. A Mac will work too. And I would say professionalism counts. And there's a reason behind this, because some students in classes that I've taught in the past have had a project or an assignment that was fairly substantial, where they talked about it on their job interview, right? So they built they wrote some code for a closed loop control system on a microcontroller, and there were some practical problems. They could talk about the practical problems, and when they had pictures. When you have pictures that you can bring, it really drives it home that this is something you did. It wasn't just an analytical assignment. It was something you got to work beyond theory. So professionalism counts. Imagine you're going to show your report to an engineer interviewing you. It just means be neat, enter the data. Okay, so for grading, homework's 20%, labs 20%, each of the 3 exams 20%. One homework grade will be dropped. Please use that for accommodating emergencies. I know sometimes we have to miss lecture or assignments, so please save it for that. We're going to use the clicker for live lecture questions and surveys, and as motivation to participate in that, responses to the clicker questions will count as 1 homework grade. So if you answer at least half of the questions, or I should say, if you answer during at least half of the clicker sessions, you'll get full credit for that homework. Okay, so those are the details, the logistics of the class. Does anybody have any questions? Either shout them out or shoot me a question in the chat about how the class will operate or anything I said so far. Okay, nothing seen in the chat. Okay, are there differences between the grad and undergrad sections? They're largely the same. I try to pose questions to the grad students during their project that will be a little more challenging. So, but largely you're going to do the same work. Okay. All right. So if you have your clickers, grab your clicker, because I want to get an idea of where everybody is in the course. Okay, so have you had breadboarding experience? Right. done anything like, once or twice, many times, you've done a lot of breadboarding, what would you say? Okay, good. It looks like we've got most of the responses, and we have a range, right? It looks like everybody has at least touched a breadboard, and I don't know what being an expert in a breadboard means, but no expert. So we fall in between. That's good. That's where I expect everybody to be. How about soldering experience? Who has soldered wires, a circuit board, um, done something with a soldering iron? Okay, looks like we've got soldering experience in the range mostly of once or twice or many times. We have an expert. We have someone who has never soldered. So what I would say is, if you've done it either never or once or twice, um, you might want to attend the workshop, one of the workshops. It's available, or alternatively, stop by the ITLL, sit down at a soldering iron, grab the staff, and just do some practicing there, because you'd rather mess up on someone else's circuit board than your project circuit board. So, but it's good to get some experience soldering, especially when you're trying to troubleshoot a circuit. Especially desoldering can be difficult, but often project assembly requires some kind of soldering. Okay, so how about printed circuit board fabrication? Have you done this? Have you either used a router in-house or sent out a circuit board for etch? Have you done layout with a software tool? Okay. All right. That's, again, kind of what I would expect in this never or once or twice. A few people have done it many times. That's good. Okay. Okay. How about uh, microcontrollers? Have you used an Arduino? Have you used many different microcontrollers? All right, that makes sense. Looks like, I would expect lots of the many of the intro courses have an Arduino as part of kind of an intro to engineering, and then if you've taken any robotics course, sometimes they use Arduinos. So if you've never used an Arduino, I'd recommend doing the ITLL workshop, because that will get you up to speed. If you spend an hour, it'll put you way ahead uh, on just coming up the learning curve about what the Arduino is and how to start up the integrated development environment and write a simple program and hit download and run, and you'll see how that works. So I'd recommend that. Okay, and how about C or C++ coding experience? Okay, good. Looks like um, we have lots of people have done it once or twice or many times. A few folks never. So again, that going to the Arduino intro workshop at the ITLL will get you up to speed on just the some of the syntax and how to call a function and how to write some basic C statements. So I'd recommend attending one of those workshops. Okay, so thank you for the input. That is very helpful. Let's see. Okay, so now what I'd like to do, I want to walk through the Canvas page just to point out some of the content. So let's see if this works. Okay, let me see if I can make it bigger to make it readable if you have a smaller screen. Okay. So I encourage you, just click through this, go to the Canvas page, click through, see so general information has where you'll find me. When the TA's information is posted, you'll have the TA here. Here's the Zoom link. Here's the schedule. So I'd recommend keeping this schedule handy because this shows you, let me zoom out a bit. The schedule, it's a PDF file. It shows you all of the lecture topics, all of the dates that we have class, right, holidays, and when the labs will be held. For example, the first lab is 9/6. Now you'll see on the lab assignment that that lab isn't due until a week later. So you'll have time to work after the lab session. But here you can see when the homework's due. You can see when we're going to have the exam. And so I'd recommend downloading this, printing this out. If it does update depending upon the pace of the class, if any due date changes, I will announce that. But generally, if the topics in lecture change, I won't announce that, but I will keep it updated on the website. Okay, there's a syllabus there, a printed syllabus. Take a look at that. Here's the Slack discussions link. So to join Slack, click on the invitation link and it'll open up Slack and you'll be able to join that Slack link. You'll get added to the topics that I have up there now, which are homework, lab, exam, general. So click on that, check that out. What else? Here are all the lecture slides. So the introduction I talked about today, that's right here. Then we're going to go into circuit theory and analysis review, test and measurements, power sources and power control, microcontrollers, sensors. So these are all the slides that we're going to cover. They're all current, but they're what I plan to present. If I make minor revisions, I'll up the rev level here. If there's anything major, I'll tell you about those. Let's see. So then what else do we have here? Lab resources. So you can look at your overall lab project schematic here. Here's a link to the workshop. So you click on that. And for example, if you want to do some work with an Arduino, click on these links and you'll be able to take a workshop, sign up for a workshop. I'd encourage, if you're interested in that, do it early because they fill up. You're going to have sign-off sheets. I'll show you where those get submitted. But so as you're building your project and you get functionality to work, you're going to demonstrate that functionality to the TA or to me, and then you're going to have it signed off. So that sign-off sheet is just you fill in your names and the lab number, and we'll sign that off, and then you submit that. And I will show you where. The source code, so that template source code that I talked about, you click on source code for the course. So when we get into using the microcontroller, you're going to go to GitHub. So here's some basic instruction on what to do on GitHub. So you click on the GitHub link. Here's my GitHub page. This is all the code you'll need for the labs. Okay. So that's where you will get your source code as a template to start. Oh, let's see here. Here's the ITL orientation link. You can check that out. Some information on the Arduino software, data sheets. Although I think I only have one data sheet there. If you need a data sheet, you can search the part number. There's a lab kit inventory. So when you get your lab kit in lab, be sure to check it against the inventory. So you have all these components. Right? You have all these components that you're going to be given. There's quantities over on the right. So if you're missing anything, it's best to find that before working the actual lab, because the ITLL doesn't stock these normally. We do have a few spares, but if we're missing something, we need to know early. What else? We'll talk about MQTT and IoT when we get there. Here's the video link. So I will post the videos linked here. So I'll post the video and then post a link here so you can see as we cover as we have lectures, you'll be able to review them or watch them. And then there are also review videos. So let me show you this. So this is the undergraduate course, Circuits and Electronics. And if you want to brush up on something like, oh, we're going to cover Thevenin equivalent circuits, you can click on Thevenin equivalent circuits and watch 5 or 10 minutes of that class that I held and just catch up on things. And if you already know capacitors and inductors, but you want to refresh yourself on, phasors, you can go watch a short video on that. These are just links into those lecture videos. So that's there. And then you'll have solutions posted as you submit homeworks. Okay. And then let me bring you also to the assignments page here. I like to sort by type. So here are all of your labs. So this is your first lab. You can take a look at this now. We'll be doing this on September, 6th, right? So this is the due date. The lab will be executed per that PDF file. That's September 6th. This is a week later when your lab's due. So you'll click on this and submit your lab. That lab doesn't have a sign off, but this lab does. So here's your DC motor driver circuit, right? And you'll get that working. And then on or before September 27th, you'll submit the sign off sheet, okay? Okay, so this shows you all the labs here as assignments. And then here are all of your homework assignments. And so when you're working homeworks, you'll see there's a PDF file that you work from, and then you're going to submit via this link right here. So work out your homework and then submit your solutions here. Okay, and again, please don't resubmit after the due time, because only the latest submission is kept. So if you submit after the due time, I don't see any record of an on-time submission. So, okay, all right. So, and then we'll have exams posted here. So there's a tour of Canvas. Go ahead and browse that. If you have any questions about that, or if any link is broken, let me know. I'll fix it. Okay. So let's see, we only have about 2.5 minutes left. So I think I'm gonna, well, first I'll say, are there any questions on anything I presented so far, the class, the format, or how the lab's going to work? All right. Okay, I don't see anything there. So, so what I'm going to do, I'm going to end class now, and let's see. So let's get some closing announcements here. So don't forget, Lab 1 is not until 9/6, so that will be that next Friday. Homework 1 is also due on 9/6, so check that out. That's already posted, and we'll cover that material, of course, as we go through the next couple lectures. If you feel you want to strengthen any review topic, definitely check out those review videos. See the recommended workshops on Canvas and sign up early, because they do fill up if you're interested in taking them. If you are a CMU student or you're taking this course remotely, please shoot me an email. Let me know. I want to make sure you have everything that you need. So that's all for today. So I will hold office hours right now. So if you'd like to stick around and just chat about the course, chat about anything, stay up on the Zoom session, and we'll start that in a few seconds. If you don't join, I'll see you next time. Have a great night.